cubo. Il prossimo anno vi faccio fare un palco più alto. Buongiorno a tutti, benvenuti alla seconda edizione del Google Developer Day. Allora, quest'anno il mio compito, io mi chiamo Giorgia Longoni, sono il direttore marketing di Google e il mio compito sarà quello di introdurre la giornata. Poi passerò subito la palla invece ai miei colleghi ingegneri che vi racconteranno meglio dei prodotti. Quest'anno il tema forte è quello di Open. Se vedete tutti i prodotti che sono stati lanciati da Google nel 2008, si muovono tutti nella stessa direzione, che è quella di sviluppare piattaforme di sviluppo aperte e di creare degli strumenti per gli sviluppatori per fare in modo di creare applicazioni web sempre più innovative in un modo sempre più efficiente. Noi ci definiamo sempre una compagnia tecnologica, no? Prima di qualsiasi cosa Google fa tecnologia. Ultimamente amiamo anche definirci come la community di sviluppatori più grande del mondo, perché i nostri prodotti sono effettivamente aperti e utilizzabili, hanno quindi la possibilità di far contribuire tutti alla crescita del web. Quest'oggi ci focalizzeremo in particolare su alcuni prodotti molto interessanti che hanno sostanzialmente tre obiettivi, no? Il primo obiettivo è quello di avvicinare il web agli utenti, quindi distribuire le applicazioni al maggior numero di utenti possibile. Se pensate a prodotti come Open Social, ad esempio, questo è un prodotto che vi permette di sviluppare applicazioni social a disposizione di tutti gli utenti senza dover spendere più tempo a cercare di integrare le applicazioni nei singoli sistemi, nelle singole interfacce, ma vi libera tempo per essere più creativi, di concentrarvi quindi sull'idea, sull'applicazione in sé, senza dover passare tempo a imparare i singoli linguaggi. Un altro obiettivo molto importante è quello di creare il web del futuro, è quello su cui stiamo lavorando con prodotti come Chrome o Android. Chrome in particolare, se ci pensate, è stato posizionato in diversi modi, un po' come il browser del futuro. Io credo che più che il browser del futuro, Chrome sia un prodotto che getta le fondamenta, quindi offre l'infrastruttura agli sviluppatori per costruire applicazioni che saranno in grado di essere gestiti dai nuovi browser, quindi le applicazioni del futuro web. Il terzo obiettivo è quello che dicevo un po' prima, quindi quello di darvi degli strumenti che vi permettano di sviluppare applicazioni in modo più efficiente, più libero, più innovativo, più aperto, con prodotti come App Engine, di cui di cui parleremo oggi in modo abbastanza approfondito, perché è un prodotto nuovo, no? Che è stato appena lanciato. Allora, rispetto allo scorso anno abbiamo preso un po' i vostri feedback, quindi abbiamo deciso di tenere una parte plenaria più corta, quindi durerà più o meno fino alle 11, e poi invece di concentrarci sulle sessioni parallele dedicate ai singoli prodotti. In particolare avete visto che vi hanno fatto scegliere le varie sessioni a cui partecipare. Ci sono dei seminari che sono delle introduzioni ai diversi prodotti e poi ci sono i Code Lab, dove invece avete la possibilità di provare live i nostri prodotti, quindi sono dei laboratori in cui potrete iniziare a programmare. Allora, le aule per le sessioni parallele sono questa, quindi dopo, quando finirà la sessione plenaria, alcuni di voi rimarranno qui, altri andranno di sopra, al primo piano, dove ci sono tutte le sessioni parallele. Una nota logistica: fuori dalle aule ci sono le cuffie per la traduzione simultanea e anche dei feedback form. Quindi usateli per favore, dateci la vostra opinione, perché veramente la prendiamo in considerazione. Infatti vedete che comunque quest'anno abbiamo un po' riorganizzato le cose per cercare di venire incontro alle vostre richieste. Altra nota: dunque alle 6 più o meno finiamo tutte le breakout session e ci ritroviamo al T35, che è il bar dove vi siete registrati, perché ci sarà la premiazione dei progetti migliori che sono stati sviluppati durante i Code Lab, quindi poi vi daremo premi e ricordo della giornata. Credo di aver finito. Aspettate che controllo. Ok. Allora, adesso vi voglio presentare, passare la parola al mio collega Brian Fitzpatrick. Molti di voi l'avranno visto l'anno scorso, chi di voi c'era alla prima edizione. È un personaggio, un'autorità, diciamo, nel campo dell'open source, perché ci lavora da 10 anni ormai, quindi lui è arrivato a Google nel 2005, però lavora su progetti open source da 10 anni, che in termini di anni internet è un'eternità, no? Quindi è veramente qualcuno che può portare una lunga storia, una lunga esperienza. E lui farà un'introduzione presentandovi i prodotti principali per gli sviluppatori. Okay? Quindi credo che non mi dilungherò oltre, passerò la palla direttamente a Fitz.
Grazie Giorgia. Io sono da Chicago, sono il primo ingegnere per Google a Chicago e abito a Chicago, però 15 anni fa ho abitato per 3 anni a Roma. Infatti io sono stato il vero americano a Roma. Però il problema è che la mia testa è come un colabrodo e non dimentico quasi niente. Ho dimenticato quasi tutto e perciò mi dispiace, però parlerò in inglese o almeno in americano. Allora, I was saying, and you might want to put your headphones on now. I'll speak slowly, however. Welcome to Google Developer Day. I'm very happy to be back in Milan for Google Developer Day this year. We as a company, we're an engineering-focused company, and we build applications just like you do, and we face a lot of the same challenges. What I'm going to talk about today is what we do for developers, why we do it, and why you should care. The web is a platform, and this is a big deal. You're not writing for Windows or for the Mac or for Linux, but your target is the web browser. We bet as a company on the open web as a platform, and our goal is to enable richer, more powerful applications. So how are we going to do that? We're going to do that by I want to talk about 3 areas that we've invested in. First, to make the client more powerful. Second, the cloud more accessible. And lastly, we want to keep connectivity pervasive. Now, what does this mean? Well, what this means is that the browser is the client. It's not just running on the client, but it is the client. For web developers, your target client is a web browser. There's no install. It's built on open standards, and it's ubiquitous. Anybody who has a computer and an internet connection most likely has a web browser, even for mobile. In fact, mobile browsers in particular are becoming increasingly more powerful. But the browser still has a long way to go until it meets the capabilities of proprietary client platforms. So note there's still a really big gap here between browser and native capability. We've come a long way from straight HTML. DOM and CSS were big steps, huge leaps towards where we are today. Even when XML HTTP request came along, you see there was a bit of a jump. It took almost a decade before things really used it, like Gmail or Google Maps. But we don't think the innovation is happening fast enough. So at Google, we think that the client, or the browser in this case, can do a lot more. So take a look at Chrome. How many people here have used Chrome? Oh, yes, excellent. Okay. Chrome is a full open source browser. And what we're trying to do is contribute to the innovation by releasing Chrome and narrow that gap that you saw in that graph. Our goal is to bring the browser to the same point as these proprietary client platforms, or even, hopefully, surpass them at some point. But let's look at how we make the cloud more accessible. Most popular websites, search, email, YouTube, eBay, MySpace, Amazon, these all require massive computational capabilities. We call those clouds. Most developers like yourselves can't afford to build a cloud, right? We as a company spend millions of dollars every quarter investing in data centers, as do a lot of these other companies that I've just mentioned. As an example, I'll talk about Google Maps. Google Maps consists of a ton of data and computational ability. business listings, satellite imagery, the maps themselves, geolocation information, terrain, roads, traffic, all these different things. And all that is part of what delivers Google Maps to you. Search, YouTube, we do machine translation for over 20 plus languages. All this takes a lot of horsepower. Most developers can't do this on their own. But our goal is to change this. Okay? If you look carefully, if you saw on the laptop here, this is my laptop, it says my other computer is a data center. And our goal is to literally make it that your other computer is a data center, that you have access to this cloud computing. So this is a little graph that shows the growth of connectivity in Italy, okay? This shows mobile phone users and internet users in Italy. If you notice, let's start with the blue line, the internet users. Currently, over half the population in Italy is connected to the internet. Now, mobile is kind of crazy. You might notice that mobile's up to almost 140%, all right? That means that there's more than one phone per person, cell phone. Who in the room has a cell phone? Okay. Who has 2 cell phones? See? You see? You guys are causing this problem. No, I'm just kidding. But mobile is way up. In 2003, you crossed 100% mobile saturation in Italy, okay? These are big numbers, okay? And growth is continuing. It's not slowing down. Connectivity is getting to a point where it's pervasive. And you as developers have to design for it. It brings you a new set of abilities, but also a new set of challenges. So what's our motivation here? Why are we doing this? Okay? These 3 areas we've talked about: making the cloud more accessible, the client more powerful, keeping connectivity pervasive. These are what drives what we're doing for you, the developer. Why are we doing this? This is different than a traditional platform play you've seen from a big company. The traditional platform play is where a company looks to convince developers to build apps on their specific platform or runtime. We say that the web is the platform and it's not owned by any one company. Why do we care? Well, we care for 2 reasons. First, we were born on the web. It's the only platform that we as a company have ever known. And the web is a platform born out of consensus. There's no one company giving you a sneak peek of what's coming soon in 3 years on the web, or not telling you what's coming. It's all of us agreeing on a few simple standards that enable this powerful applications. Standards are what created the net and the web platform. The web platform emerged on top of these standards. And Google comes from a world of consensus and partnership. It's intrinsic to our culture, not just from the small teams, but our company as a whole. Our founders, Larry and Sergey, have said they believe Google owes a great debt of gratitude to the web and open source. And they did amazing things back in their dorm room at Stanford in 1995, but that's only because they stood on the shoulders of giants. The second reason, and I'm going to be frank here, is this benefits us as a company economically. As the web improves, you get more and better web applications. Then you get more users, okay? And then we all benefit. For Google, more users means more usage of the web, and that means that we make more money. And it's in our interest to help the web continue to grow as this platform. And from that revenue that we make, we actually invest millions of dollars into technology that we open source and then give away. Projects like Google Chrome, Gears, Google Web Toolkit, Open Social, Android, and over 100 more open source projects you can find on code.google.com. These are all open source projects where we pay engineers to develop the software and then give it back to the community. So I want to talk first about client. Our goal is to narrow the gap from the browser, remember, to these other proprietary platforms. And our biggest effort in doing this is a web browser called Chrome. Now I love this slide. Okay, this is Amazon.com in 1995. Who here remembers the web in 1995? Who used the web in 1995? Oh man, I'm old. This is a huge evolution to the day. On the right, Google Street View, 2008. 13 years, tremendous change. Today, apps are pushing the envelope of a modern web browser. And many techniques for Ajax just started off as hacks that weren't intended to work in a browser. For example, using iframes for cross-domain communication. Chrome, however, was built for the web of today. It was built from scratch for today's developers' needs, as well as to serve the user better. There are some very important underlying components of Chrome. First, it's completely an open source application. It's built on WebKit, which is an open source rendering engine. We found that WebKit did the job of rendering pretty well, so why reinvent that wheel? It's also built on a JavaScript interpreter called V8, it's also open source, and it was built and designed by a team from Google, mainly to be fast, and it is crazy fast. And that's important when you're writing more sophisticated web applications. So, lastly, Chrome is built on a multi-process model. That's for stability as well as speed. So I'm going to do a quick demo to show you Chrome and some of the neat things you can do with that. Can we switch to the other computer? So here we have, this is Chrome, and we've got a few tabs already open and ready to go here. Google Calendar, iGoogle, YouTube, and Google News. Okay? Now, just a regular web browser, you can scroll up and down. But let's take a quick look here at the task manager, okay? If you take a look at this, you can see the multi-processes that are running. There's one process for each tab, and there's also down here a process for the plugin. Now, I have this neat little bookmark I've created here called Simulate Hang that's going to throw my current page into an infinite loop. Okay, notice here, suddenly it's using a whole lot of CPU. I can't click on it. Nothing works in this page, pretty much. Can't type, nothing. However, the rest of the browser is still working. I can still do things. Look at Calendar, iGoogle. I can still type in here if I want to, okay? So let's go back to this page, and I can see pretty much it's clear that this is using it. And boom. I just killed this one tab. Notice this still works. The rest of the browser is still here. You didn't lose all of your state. Typically, you have many tabs open. And the great thing about it is all I have to do is click reload, and everything's back. Just that easy, okay? For another quick example here, we'll go to YouTube. We'll start playing our little Flash movie here. Now, in some cases, a Flash app will go crazy and start taking over your application. So here, I'm going to go back to the task manager, and there's my plugin. You can see it's currently using 4% of the CPU. Boom. Terminate process. Just killed it. Now, the rest of the page still works. You can still move around. And to get started again, it's just as simple as hitting reload, and everything's fine. Right? And it didn't affect any of my other tabs. Everything else is still here and still works just fine. So the last thing I want to show you as part of this quick demo is creating an application shortcut. All right? So if I come over here, you notice this simple little menu option. And I'll tell it to put one on the desktop for me. And now if I go to my desktop and close up these windows, you'll see that there's a shortcut for Google Calendar. Voila. You can go straight to Google Calendar from the desktop. Can you switch back to the other projector, please? So that's just a couple of the really great benefits of Google Chrome. And you'll notice more than anything that it's just screaming fast. But it's built on top of an open source project that we call Chromium, okay? Which is released under a permissive license called a BSD license. And our goal is to encourage others to adopt ideas from Chrome because we're adopting ideas from other browsers as well. For more, Mods has a talk later today on Google Chrome, and I suggest you check that out. I'm going to move on to Gears. Gears is an open source plugin. It's included in Chrome, but it also works in IE and Firefox. Its goal was to improve the basic functionality of all web browsers and extending them to enable rich applications that used to be only possible on desktops. So in our first release, we wanted to put 3 things out there. The first main feature was a local server for offline usage. Wait a minute, offline? What's offline? Aren't we having this pervasive connectivity? believe it or not, there's still sometimes when you're offline, which is kind of sad. So secondly, a local database for storage of data, so caching things. And lastly, worker pools for computation so that you can do a little bit of work without locking up the user's browser. Now, Gears 0.4 launched just a few weeks ago with some notable improvements. First of all, a geolocation API, which allows you to access the location of the user based on their IP address, their cell ID, or their GPS, with a simple JavaScript call if the users give you permission. It's important that the user's in control of this information. Now, today, I'm actually very honored to announce that we've added Wi-Fi signals to the geolocation API, which allows developers to get under 200 meters of accuracy as to where a user is in the world. Now, Brad has a Gears talk on that. I'm not going to spoil all of his surprises, but if you're more interested in Gears and how you can do this, definitely check out this talk. So the second thing is the Blob API, which makes it easier to access files. And lastly, an on-progress indicator for HTTP uploads and downloads. There's plenty more on this, though, so please check out the Gears talk if you'd like to know more about that. So now let's talk a little about the cloud. We want to make our cloud more accessible to developers. So that means that we need to provide programmatic access to computational resources that we've developed. First of all, that means APIs. And we have two different kinds of APIs that we provide. The first are Google Data APIs. For example, YouTube, Contacts, Calendar, Blogger, Docs, Spreadsheets, dozens more. What they provide is authenticated access to applications and data that our users have put there. So you can use this to build deep integration from our products into yours. For example, you can access calendar events, contacts, and you can get that as XML or JavaScript, and then render that as part of your application. You can also programmatically create calendar entries or contacts. So this is very powerful and enables you to provide a richer integration with our products in something you're writing. The second kind of API is our AJAX APIs. This basically gives you JavaScript access to the public web that we crawl and recrawl and recrawl over and over again. This is a set of read-only REST APIs that give you a way to query things like local listings in Google Maps. You can search across YouTube, Google News headlines, books, images, blog search, web search, even our automatic machine translation capabilities. So together, the Google Data APIs and the AJAX APIs give you programmatic access to our cloud in almost every product we have. And our usage continues to grow, as you can see from this very vague graph that has no numbers on it anywhere. But I'll tell you one statistic. We currently serve over 1 billion requests every day for our APIs. So you probably want even more cloud access. I'm really happy that we've recently released App Engine, which lets you run your apps in our data centers, taking advantage of our scalable infrastructure. It's pretty new, so I want to talk a little bit about what App Engine is. First of all, it's got a really cool logo. It's like a plane without the people, all right? But it's a system for running scalable applications on our infrastructure. What you do is write Python, you upload it, and we serve it. And it's currently in a preview release, so that means that you get up to 5 million page view requests for your application a month. Once the preview release is over, you'll be able to pay for things over your quota like computation, storage, and bandwidth. But we built this because launching at internet scale is really hard for developers. Now that there's so many users on the internet, if you want to launch an application, you have to set up a server like Linux, then you have to configure Apache. You have to configure your database and your SQL database, whatever it might be. Then you have to test it and integrate it with your front-end stuff. Oh, and when you're done with that, you have to find a hosting place, right? You have to get machines. You have to spend a lot of money. You have to set up monitoring. Don't forget to go through your logs. And then as you get more popular, you have to maintain this. As you get more and more users, you have new challenges. You need to get more machines. You need to load balance. You need to optimize. This is a lot of hassle, even for a simple app. Why should you have to do this? What do you want to do? You want to write applications, right? So we make it easy to get started and then to scale with App Engine. So you write your code, you test it locally on your SDK, your developer kit, then it's simple as clicking a button to deploy it to Google. And if you wrote it carefully using our APIs, your app can scale to millions of users. Now this is just launched, but already there's some really cool apps available for App Engine. This one's called Wordle, and it's at wordle.net. It's a really cool app. You can create word clouds based on text that you provide. You can either copy and paste a bunch of text into it, or just point it to a URL of a web page or a feed. You can see I created this in less than a minute by just putting in the URL for App Engine itself, the blog. So it just looks at the frequency of the words and then gives more prominence to words that show up more often. And you can change colors and fonts and all that sort of stuff. But still, you will be careful if you go here. You'll waste at least an hour. It's just a lot of fun. BuddyPoke is another example. This is actually one of the most popular open social apps on Orkut and other social networking sites. It enables users to have a personalized 3D avatar that they can use to express themselves and interact with their friends. When Orkut opened up open social apps to Brazilian users, BuddyPoke, their rate of installed instantly increased by a factor of 8. Since they used App Engine, they were able to handle that increased load effectively without having to scramble around and build more of a data center or cloud themselves. The last one I'm going to point out real quick is Pixverse. They made out really interactive open social apps, a couple of them, PixChat and PixWall. And they were one of the very first companies to use App Engine. And as you can see from the quote, we were really excited to see them get their application up and running so quickly. And this, again, ties back to why we created App Engine, to make it easy to start and scale your apps. So I want to touch on connectivity quickly. You saw the great explosion in wireless connectivity. This has been fabulous for users, but not so much for developers, because there's a lot of different mobile platforms out there. Some of them have different open parts, some of them have different closed parts. What we need is tools and standards, a platform open to everyone, carriers, manufacturers, developers, and especially users. It should be just like the web. So we invested in a project that we call Android. It's a completely open source, world-class, we think, mobile stack, top to bottom. It's part of what we call the Open Handset Alliance. It's a partnership of 34 companies that came together around developing this. And we hope that the mobile industry will embrace this open source stack for development purposes. Being best for the users is being one goal, and the other goal is to make your life easier as developers. And there's an introduction to Android this afternoon at 4, which is something you might want to check out if you're interested in Android development. So I'm not going to spoil too many interesting surprises there. So I've touched on client, cloud, and connectivity. Now I want to talk about a couple of quick things that touch on all of these areas. The first one of these is the Google Web Toolkit, which is designed to make development easier. And for that, I'm going to ask Andrew Bowers, the product manager for the Google Web Toolkit, to come up and do a quick demo and talk to you a bit about it. Andrew?
So you may have noticed two things so far. One, that we want to make development, and web development in particular, easier for developers. And two, we like things to be really fast. And so those are two things you're going to notice about Google Web Toolkit. Now, browsers these days are actually pretty capable in the things they can do. However, in order to take full advantage of that, you have to be a JavaScript expert, you have to know all the differences between the browsers, and you probably have to have a lot of time on your hands to actually develop it. Alternatively, you could have a set of tools to help you out. That's where Google Web Toolkit comes in. Google Web Toolkit allows you to develop in the Java programming language. It then cross-compiles that Java source code into JavaScript. And this is highly optimized JavaScript for multiple browsers. So it tailors specifically to the browser that the user is using, and it does the fastest, most performant thing for that particular browser. So that means that you have to spend less time worrying about browser quirks, browser differences, and you can spend more time on building functionality for your end app and your end users. Now, this is plain old JavaScript. There's no GWT or Google Web Toolkit runtime on the back end. It's just plain JavaScript that can be served from any server. So that means that you don't have to have Java on your back end. You can be serving that from anywhere. Now, this approach provides two fundamental things. First, it provides productivity for a developer. Because you get to develop in Java, you can create abstractions and very maintainable code. But then we're compiling, so it provides performance for the end user, so your end users don't suffer because of your development model. So if we can switch computers, I'd like to show you what that looks like. Can we switch over to the other computer? Great. So productivity comes in a couple of places. So first of all, because we're developing in Java, we can use all of the existing Java tools that are out there. And there's some pretty fantastic tools. This is the Eclipse development environment, and it has a lot of things that make development easier. Code navigation, you have refactoring. So this is something that, it's just Eclipse, and it's been around for a while. But the nice thing is, if we want to refactor something, I did web development for a long time, and I forgot that I was developing in Notepad or maybe VI, and you forget that you can do some of these things. So here I'll just change this to images, and I changed that method signature, and it was a lot quicker than the old copy and paste and going through my code and figuring it out. So that's a nice thing. Now, when you hear compile, you may think, does that mean that I'm going to have to compile my source code every time to see a change? Well, we wanted to make this as close to web development and JavaScript development as possible. So that's where something called the Google Web Toolkit hosted mode browser comes in. The hosted mode browser takes your Java source code, it runs it as bytecode in the JVM, in the Java Virtual Machine, but it drives an actual web browser interface. In this case, because I'm on a PC here, it's driving Internet Explorer. It's the system default. So this means that you can develop here's a mail sample from the GWT distribution, and it's just a simple Ajax front end. There's no back end here, and it's showing you an Ajax app. This is actually Java bytecode that's running on the back end. What this means is that you can do some nice development work, and you can move along just as you would with JavaScript. So for instance, if we look down here at this contacts label, maybe I want to change that. So I'm just going to go over here to my development environment. Here is where we're setting that name. Let's say I'll set it to Italian. I want to save. I'm going to go back over to my hosted mode browser, and I'm going to click refresh, just like you would in a web browser. And you can see that that's changed. Okay, that's kind of neat, but that's not too exciting, huh? But the nice thing is you can also debug. Because we're running, once again, Java bytecode, we can step through the code. So I'm going to go back down to this contacts panel. And now I've set a breakpoint on the click listener for these links. So when I click it, you can see that Eclipse is saying something. So it's now jumped to the place in the code. And I can step through this code. I can inspect variables. So see, I'm inspecting variables down here, and I can actually see the underlying DOM structure that we're using right down here. And I can get it going again. And now the pop-up has shown up. So that's some of the nice productivity gains that you get. But we're also compiling. So the performance side of this means that we can do a lot of optimizations that you wouldn't do if you were writing code by hand. And you can develop in a more object-oriented and maintainable way. We can do dead code removal, things that you aren't using and you left in your code perhaps. We can do obfuscation, so shortening down names across your application to make the JavaScript download smaller. And we can also do a lot of performance optimizations like inlining. That means that we take your code, the compiler does multiple passes over it, and where possible, it takes method calls and actually inlines those where appropriate. So it will actually take method bodies and inline that into the area where you're calling that method so that you don't have the overhead of going and making a call. Now, I'm going to show you an example of that. So I'm just going to close this down here. And I'm going to go to another example I have here. my hello.java. So this is a very simple example, but very complex code. And all it does is going to open up an alert window that says hello world. Okay, that's pretty simple. I bet everyone here knows how to do that in JavaScript. Well, the person that wrote this apparently just learned Java, and they used all the Java features that they could to show off. So here we have an interface, which is phrase strategy, and a hello strategy class. Now that implements hello. That's pretty useful. And a world strategy, that implements world. Wow, this is impressive. Now it gets really impressive with combinator, which is combining hello and world. And it's even using generics. That's pretty fancy, huh? That's a Java 5 feature. And then we have get. I'm going to skip that one and come back to it. We have get message, which is putting this all together. It's creating those classes, and then it's combining them and returning that value. And then we have on module load, which is the equivalent of main in a Java program for GWT. And so here we're calling window.alert and get message. So that's a lot of code just to say hello world. And obviously this is a contrived example. But you're probably wondering, or you're probably saying to yourself, well, that's a lot of code to do just that. Well, the compiler thinks so as well. And so if we can switch back over to the other slides, I'd like to show you what that compiles down to. Can we switch back? It's going to compile down to this. It's simply a string that says hello world. So the compiler has gone through those classes through multiple passes, and it's seen where it can optimize and where they're final variables, and it will inline those to this. So it's a very powerful programming model, and we do think that you get a lot of productivity by developing in this abstract, object-oriented way, but yet you don't suffer any performance hits, and actually you benefit because you're able to get a lot of performance gains because we are optimizing for each web browser, and you, the developer, don't have to worry about those. You can build the best app possible. So please try it out. I don't think you'll be disappointed if you do. I'll hand it back to Fitz.
Thanks a lot. I'm very, very proud and honored to be involved with the Google Web Toolkit guys. I helped them out when they went open source. It's a completely open source under an Apache license. Before I go on, I want to ask real quick, who in here writes JavaScript? Okay, who in here has used the Google Web Toolkit? Okay, you have to go to this session. JavaScript is for people who like to write code. Google Web Toolkit is for people who like to write applications. I mean that. It's going to save you a heck of a lot of time and allow you to concentrate and do incredible stuff. It's an amazing product. So, another thing that spans all three of these areas of client, cloud, and connectivity is the social web, which is evolving in the same way that the internet did. It's based on consensus around simple standards, and this is what open social is all about. It's about making the web more social, creating more and better social apps for end users, and making it easy for developers to participate in the social web. At the very base level, it's a set of APIs. The community has defined these and agreed upon them. So developers can use a single programming model across participating websites. This includes a REST protocol, which gives you server-side access to various social sites. And these are being rolled out as we speak as part of Open Social 0.8. But to give you an idea of how many users we're accessing here, you can write a single app and with some minor modifications have it work on all the websites that participate in Open Social. Currently, that's got a total reach of over 350 million users. Netlog and Hives have just launched Open Social, which adds another 40 million users to that. So we're talking about 390 million users on the social web. And we've been really surprised at how it's grown into a vibrant community of developers, containers, and applications, and of course, finally, users. So Open Social is an open standard. It's nurtured by an open community and a nonprofit organization, the Open Social Foundation, which you can see on opensocial.org. There's also a reference implementation called Shindig at the Apache Software Foundation, which makes it easier for sites who are adopting Open Social to launch quickly by using Shindig. You know, you've probably all heard of the Apache Software Foundation. over 50% of the web servers on the net run the Apache web server. There's Tomcat. There's tons of other applications that Apache nurtures and grows. But Apache isn't just about code, open source code, there's tons of it. Apache builds communities around this. So we're really proud to be building the reference implementation alongside other open source committers at the Apache Software Foundation. It's about the community. We've got a session and a code lab about Open Social today, so you can take a look at those if you're interested. And I can't wait to see some of the great apps you guys are going to build with that. So with that said, I hope that this talk gave you guys a glimpse into some of the things that we're doing for developers. And this is only the tip of the iceberg. The rest of the day, we've got a lot of really in-depth technical sessions and code labs. And the last thing I want to leave you with is that the web is the preeminent platform of our time. And it doesn't belong to one company. It belongs to you. It belongs to us. It is our platform. So together, we can continue to innovate and move it forward. And I'll be around for the rest of the day to discuss this with any of you who are interested. And I hope you really enjoy your day. Thanks a lot.
Grazie Fitz. Ok ragazzi, adesso vi dovete dividere seguendo la vostra agenda, diciamo, no? Quindi parte di voi rimarrà qui e gli altri andranno al primo piano dove ci sono sia i seminari che i code lab.